Good evening, everyone. Uh, the topic of our project is vessel trajectory prediction models for marine traffic control near Beaumont-Port, Port Arthur ports, Texas. I'm Zaki Ahmed Choudhury, and our other group members are Kushum K C and Rakshya Shrestha. So, before we start our modeling, we have to select a certain part of geographic area where we want to collect the data from. We collected AIS data for a certain area. Here we can see the ports of Texas. They all lie along the coast of the Gulf of Mexico. The two ports where we concentrated our research was Port of Beaumont and Port of Port Arthur. We have also the Port of Orange here, and the maritime traffic from all these ports come and go through the Natchez Sabine waterway. And ultimately, when they enter the Natchez Sabine enterway, they do it through the Sabine Pass. And they also come out of this area. We can see that all those two or three ports are concentrated at a certain area, and to continue our simulation we collected data from an area that is big enough to get sufficient data. The area we chose was 3 degrees of latitude and 3 degrees of longitude. So that makes almost 200 miles of width, an area of 200 miles of width and 200 miles of length. First, we had to download the data of a certain geographical area. Then we filtered the data first according first according to the latitude and longitude, and then we have to uh, discard certain data where we didn't have sufficient information. We also uh, discarded data where the vessels had a speed that was less than zero point 0.5 nautical miles, because those most of these vessels are stationary, and so we had to discard those data. We also discarded other data, for example, the where the draft were not present, and also those data where the length of the ship was absent. Now our other group members to narrate their related parts. Thank you.
So I'm Kushum K C. Let's start from the data after the data filtering part. So after the data filtering, our data frame looked something like that. It has the MMSI, latitude, longitude, SOC, COC, and all the data is like with uh, which can be used for the modeling. So after that, we need to pre-process the data. So we have latitude and longitude, and our main aim behind defining the predicting the trajectory was to define new location, which is the latitude and longitude of the for the time n+1. So the column was introduced, which was named as lat shift, which is basically the latitude of the next location of the same ship while it travels through a trajectory. And also the indicators were introduced in the different column. So for defining the for assigning the values on the indicators, first latitude difference and longitude difference were calculated, and then defining whether the direction is north, east, west, or south. the values of zeros and one were assigned. So after the datas were filtered, we moved to check the collinearity between the parameters of our uh, variables available. So along our x variables, various parameters, among the various parameters available, the heat maps was plot, and seeing the heat map, the more correlated variables were avoided in the same model. Also, the VIF factor was plotted. So for the VIF factor, the values for VIF factor near to 1 was more preferred, like, because if the value is greater than 10, it generally indicates that there is high multicollinearity in the model. So for for like for for checking the parameters to be used in any model, first VIF factors was checked, and the parameters having high VIF factors was avoided in the same model. So in our model, as latitude and longitude has high VIF factors, so while using latitude in one model, we avoid the longitude on the same one. So for our model would be like the latitude for trajectory prediction for latitude in one, and the other model would continue the same parameters for the longitude only. So first, for the linear programming, for the first thing we did was like uh, we need to have our data sets into the testing data and training data. Our final data set would contain around 6 lakhs data. So 80% of data were used as a training data set, which would include more than 5 lakhs of the data, and the remaining 20% would be used for the testing the model made using the training data set. So for the first model, as I already said, our model would have latitude prediction as a separate parameters and the longitude as a separate one. So modeling would be done differently for the latitude and longitude. So for the first model, we take the x independent variable x as latitude, COC, and heading, and the y variable would be y lat for one model and one y long for other model. And we compare this y lat with the lat shift that we have created during the pre-processing of our data. So using our code, we we prepared the model using the training data set, and then we uh, get the summary of that our R square value of the linear program model using this x variables was near to 1, which is 0.09, which is really a good one. And also our confidence interval, they are all on the same side, which means it doesn't include the zeros, and the p values are greater than 0 are less than 0.05. So the model is somehow good. And the for the determination of the plot of the errors, we use the line plot, which gave the plot of scatter plot of the red dots. And for plotting our observed latitude versus the predicted latitude, we used observed versus predicted plot, in which the dots were seen more confined towards the center zone, and they are pretty much less spaced, which means that they form along a diagonal line, which means the model we created is pretty much fair. And this one is the normality test done for the errors, and this is done by the S line. And we also created a contingency matrix. So contingency matrix was plotted to determine the performance of the model that we created using the linear regression method. And the contingency matrix having the diagonal element higher values than the non-diagonal elements represents that it has more true positive and true positive values and true negative values than the false values. So the model is similar and fine for this one. And and for the longitudes, the same process and same steps were carried out, and the confusion matrix was created, and it shows the similar results as that of the latitude. So for the second model, I would like to call Rakshya.
Hello, this is Rakshya Shrestha, and we have created the second model by using three independent variables, which are latitude, COZ, and length. And we did the coding by similar process, and we got R square value as very high. So this is like good. So, and then we got p value as less than 0.05. Uh, so they are all statistically significant. Then we go next we found the ci value that is less than 0 or greater than 0. It doesn't contain 0, so it shows that our model is fine. So after that we created a contingency table. In contingency table we can see that the true positive and true negative are very high than and then the non-diagonal values. So now we can say that the model performed good. So this is so the first one is for the training one, and second one is for the testing one. Now next we perform logistic regression. In logistic regression we just imported all the libraries and then set it all the working directory. Then we read the file and we define the variables. Our variables are oh, so we took variables as uh, latitude. For latitude we took variables as latitude, COG, uh, headings, and so latitude. And after that we normalize them because in logistic it only takes a normalized value which is from 0 to 1 log. So after that we splitted the data into testing and training. Then now we fitted the models by using the building function. After that we then uh, took the output values as in the form of probability. Next we got our parameters, which are so we can see that our accuracy is 0.52. Precision is also in that range, and recall is also in that range. So we can say that our model is just a little better. After that, we plotted ROC curve. So from ROC curve, here we can see the ROC curve for latitude, and this is for longitude. ROC curve. So area under the for longitude, the area under the curve seems to be like fairly near 1. So this is like um, a really good. It shows that the positive true value is high. So yeah, but in longitude we just got our value just a little bit better than the random classifier. Then after that we we did the we found took out the confusion matrix, and from confusion matrix we can see that our uh, true positive and true negative are really high than the other. Then in but it seems that the result is better for the testing than the training one. So this is our closing statement. In we did like logistic regression and linear regression. Here we predicted the direction of the trajectory. So latitude and longitude we predicted it accurately for time ti. And we can see that the from logistic regression our area under curve value seems to be really high for longitude. So our model seems to be performing okay.